Hello students, today I am going to explain you how to balance the equations, right? How to balance the redox reactions. For that we have four steps. The first step is oxidation reduction reaction. The first step is, that means we need to find which compound is undergoing oxidation, which compound is undergoing reduction. Here we have four compounds. Among these, so you need to find which one is undergoing oxidation and which one is undergoing reduction. That is the first step. Second step, you need to calculate the n factor. And the third step is, after finding the n factor, we need to assign the stoichiometric coefficients. By using that n factor, we need to assign the stoichiometric coefficient oppositely. That I will show you. Right? First, calculate what is oxidation reaction, what is the reduction reaction. The second step, calculate the n factor. After calculating the n factor, assign those n factor as stoichiometric coefficient, right, oppositely, right. The fourth one, hit and rail metal. We need to balance the remaining atoms, right. To balance the hydrogens, give H plus. To balance the hydrogens, give H plus. To balance the oxygen, add water molecules to the opposite side. To balance the hydrogens, add H plus to the opposite side, right? So to balance the oxygen, add water to the opposite side, right? I repeat again. First, find what is the oxidation reaction, what is the reduction reaction. First step. Second step, calculate the n factor. Third step, assign the n factor as stoichiometric coefficient oppositely, right? Fourth step, so to balance the hydrogens, add H plus to the another side, right? To balance oxygen, add water molecule to the another side, right? And finally, balance the remaining elements to get the fully balanced equation. Now coming to here, first find what is oxidation reaction and what is the reduction reaction. As we know, the decrease in the oxidation number is reduction, the increase in oxidation number is oxidation reaction. First find the oxidation numbers. Here Mn is plus 7. Okay, so hydrogen, the sulfur is minus 2. Okay, the sulfur is minus 2. Here the sulfur is 0. Mn is plus 2. Okay, so first find the oxidation state, right? As we know, the increase, Leo says Z, right? We have the code, right? Leo says Z. So loss of electron is oxidation, gain of electron is reduction. After finding the oxidation number, we need to find which is undergoing oxidation, which is undergoing reduction. So we have, right, decrease in oxidation number is reduction. Increase in oxidation number is oxidation. Right? Remember those 2 points. Decrease in oxidation number is reduction. Increase in oxidation number is oxidation. If you see here Mn, so here what is happening? Here the decrease in oxidation number is happening. So this is reduction reaction. Okay. So if you observe the sulfur, there is increase in oxidation number. So this is oxidation reaction. The first step is over, right? As soon as you see the reaction, write the oxidation numbers. After writing the oxidation numbers, find what is reduction reaction and what is oxidation reaction, right? And then calculate the n factor. Here what is the n factor? So plus 7 to plus 2. So for this MnO4 minus, the n factor is 5, right? So for this reduction reaction, the n factor is 5. Okay. For oxidation reaction, the n factor is 2. N factor is nothing but the change in the number of electrons per entity. Change in the oxidation number per entity. N factor is nothing but the change in the oxidation number per entity. Here how the oxidation number is changed? 5. So N factor is 5. Here come to here, hydrogen sulfide and sulfide. Change in the N factor. Hydrogen sulfide and sulfur, change in the N factor. How much here? It is 2. So the N factor is 2. The third step, we need to assign the N factor oppositely. The third step is, we need to assign the N factor oppositely. That means observe carefully here, right? I am writing the equation again here. I am writing the equation MnO4 minus plus H2S gives rise to S plus Mn2 plus. This is the equation. First find the oxidation number over then find the what is oxidation reaction and what is the reduction reaction. Right? Oxidation means increase in oxidation number, reduction means decrease in oxidation number. Next find the n factor. Next find the n factor. So here for MnO4 the n factor is coming as 5. For this reaction the n factor is the n factor is coming as 5. Give this n factor to the H2S, right? Give that value to H2S. I told you we need to assign oppositely. We need to assign the stoichiometric coefficient oppositely. So here reaction. So n factor for MnO4 minus is 5. Here n factor for MnO4 minus is 5. The change is 5. So that 5 I will give for H2S. So that's what I said. Assign the n factor oppositely. For H2S I have given, right? So for H2S the n factor is 2. That I will give to manganese over here, right? Manganese over here. Then balance the atoms. Here there are 2 manganese. So put 2 over here. Here there are 5 sulfurs, 5 sulfur atom. So put 5 over here. Okay. Put 5 over here, 5s. Right? Then balance the oxygen atoms. Then balance the oxygen atoms. In reaction, in this side there are 8 oxygen atoms. In this side, in this reaction, there are 8 oxygen atoms. Right? So put 4H2O over here. In this reaction here there are 8 oxygen atoms. So put 8 oxygen atoms. Put 8H2O over here. Put 8H2O over here. So now we need to balance the hydrogens. Now we need to balance the hydrogens. See here how many hydrogens are there? 16 hydrogens are there. Here only 10 hydrogens are there. So hydrogens we need to balance. Hydrogens we need to balance by putting 6H plus, right? 6H plus, right? Now check everything. 2 manganese atoms, 2 manganese atoms, 2 manganese atoms, right? So 5 sulfur atoms, 5 sulfur atoms. Here 16 hydrogens, 16 hydrogens. Okay. Now we are coming to the oxygen, 8 oxygen atoms, 8 oxygen atoms. Now the equation of atoms are balanced. Now we need to balance the charges. Now we need to balance the charges. Then you need to check for the charges. If you check here, right, 6 plus 2 minus, right, 6 plus 2 minus. So 6 plus 2 minus means 4 positive. Plus 6, 2 minus. Net charge is, or net positive charge is 6. Net negative charge is 2 minus. So 4 positive charge. If you coming to here, 2 into 2, 4 plus. Right? Charge also is equal. Charge also equal. So we can say the equation is balanced. In such a way, we need to balance the equation. Now we are going to solve the IIT-JEE and NEET questions. This is the previous year question. This is the previous year question. In this question, we are going to find the coefficients for MnO4 minus, C2O4 minus, H plus. We are going to find the coefficients for MnO4 minus, C2O4 minus and H plus. So now what we will do? First find the oxidation numbers. Here Mn is plus 7, Mn is plus 2. Okay. Mn is here plus 7, there Mn is plus 2. Here minus 8 plus 3, right? Carbon is plus 3. Here the oxidation number of carbon is plus 3. Okay. Here the oxidation number of carbon is plus 4. Oxidation number of carbon is plus 4. Right? Now we have all oxidation numbers. So leave while calculating while balancing the redox reactions, leave hydrogens and oxygens. Leave these hydrogens and oxygens. So first find the remaining element oxidation numbers. That is the trick actually. Right? Leave hydrogen and oxygens. The remaining elements oxidation number you need to calculate. Here manganese is plus 7, plus 2. Carbon here it is plus 3, there plus 4. Right? First there is decrease in oxidation number. So this is undergoing reduction. This manganese is undergoing reduction. So n factor is, so the change in the oxidation number per entity, here the change is 5. So n factor is 5 over here. N factor is 5 over here. Next coming to here, carbon plus 3 to plus 4. Plus 3 to plus 4. Right? So increase in oxidation number is there. Increase in oxidation number is there. So this is oxidation. This is oxidation. Observe carefully. Here we need to find the n factor. The change is 1 only. The change is 1 only. Plus 3 to plus 4, 1 only. But the oxidation number is total change per entity. So here 2 carbon atoms are there. So the n factor is 2. Right? Students often do mistake here. They will simply take 1. Why? Plus 3 to plus 4. 1. No, not like that. per entity we need to calculate, right? Per entity we need to calculate. For one carbon it is 1, so there are 2 carbons, the n factor for them it is 2, right? So first we have calculated the oxidation states, then we have calculated the n factor. Now we need to assign them oppositely. This 5 belongs to MnO4 minus, so I will give it to C2O4 2 minus, right? So this 2 belongs to C2O4 2 minus, this 2 belongs to C2O4 2 minus, that I will give to MnO4 2 minus. So I will write 2MnO4 minus, right? 2MnO4 minus plus 5C2O4 2 minus. Okay, here as it will come Mn plus 2 plus CO2 plus H2. What I told you, first balance other than hydrogen or oxygens. First balance other than hydrogen or oxygen atoms, then balance oxygen atoms, finally you balance hydrogen atoms. Finally you balance hydrogen atoms, then mistakes won't come. Okay. First, how many manganese are there? 2. So I am going to put 2 over here. How many carbons are there? 10. How many carbons are there? 10. So I am going to put 10 over here. Okay. So manganese and carbon atoms are balanced. Manganese and carbon atoms are balanced. Then we need to balance the oxygens. Here you see, how many oxygens are there? 20, right? 28 oxygens are there. 5 4s are 20. Right, 4 2s are 8. 28 oxygen atoms are there. Right, I am writing over here. 28 oxygen atoms are there. If you check here 20. Okay, here 20 oxygen atoms are there. 20 oxygen atoms are there. Still I need 8 more oxygen atoms, so I put 8 over here. I repeat, here 28 oxygen atoms are there. Here, right? So 20 oxygen atoms are there. I need 8 more oxygen atoms, so I put 8 H2O over here. Now we need to balance the hydrogen atoms. Now you need to balance the hydrogen atoms. Why? Finally we need to balance the hydrogen atoms. If you balance hydrogen atoms, so 8H2 over here. So here 16H plus will come. 8H2 over there. Here 16H2 plus will come. Right? So in such a way we can balance. Now check for the charges. Check the charges. If charges come equal, almost your balancing reaction is correct. If charges equal both sides, your balancing reaction is correct. If we check charges, 16 positive, 2 negative, 16 positive, 2 negative, 10 negative, right? 16 positive, okay, 2 negative, 10 negative. So what is the total? So 4 positive. This side 4 positive, 16 positive, right? Minus 12 negative. So this side totally 4 positive. If you check over here, see 2 2 are 4 positive. Both sides we get 4 positive, 4 positive. So this reaction is balanced. Now we are going to answer over here, right? So MnO4 minus, the coefficient is 2. C2O4 2 minus, the coefficient is 5. For H plus, the coefficient is 16, right? In such a way, we need to answer these questions, right? We will do some more problems in some more PVQs in IIT-JEE and NEET. We are going to solve this question. This is also previous year question, right? First what I told you, find the oxidation numbers. Find the oxidation number for other than oxygen and hydrogen. Find the oxidation number for other than hydrogen and oxygen. If you write here, so for this chlorine it is 7. Chlorine it is 7. For manganese it is 4. For manganese that is 4. Here chlorine, right? Here chlorine, what we will get? Plus 7. Same plus 7. Chlorine also, plus 1. Sorry. Here chlorine it is plus 1. This is X is the stoichiometric coefficient. X is the stoichiometric coefficient. Here chlorine oxidation state is plus 1. Right. Here manganese oxidation state plus 6. Manganese oxidation state plus 6. So other than hydrogen and oxygen, we have calculated the oxidation states. Here chlorine oxidation state is plus 7. Manganese oxidation state is plus 4. Chlorine oxidation state is plus 1. Manganese oxidation state is plus 6. Right? Plus 6 water. Now what do we have to do? We need to calculate the n factor. The second step is we need to calculate the n factor. So here the n factor for chlorine is 6. Okay. The n factor for chlorine is 6. So the n factor for chlorine is 6. Okay. So here there is decrease in oxidation number. so the decrease in oxidation number, so it is undergoing reduction. So if this is undergoing reduction, so there is decrease in oxidation number chlorine, so it is undergoing reduction. The compound which is undergoing reduction is act as oxidizing agent. This is very important, right? Oxidizing agent. The compound which is undergoing reduction acts as oxidizing agent. Well, come to here. If you come to here, manganese plus 4 to plus 6, plus 4 to plus 6, right? So there is increase in the oxidation number, so it is oxidation. Increase in oxidation number, so it is oxidation. So the compound which is undergoing oxidation acts as reducing agent. The compound which is undergoing oxidation acts as reducing agent. So now we have the answers for these two. So which is undergoing oxidation over here? Which is undergoing oxidation? Here the manganese is undergoing oxidation. So MnO2 is undergoing oxidation. Why? There is increase in oxidation number, so we can say the MnO2 is undergoing oxidation. Which acts as reducing agent? So the compound which undergoes oxidation acts as reducing agent. So here MnO2 acting like a reducing agent. So here for both the answers are MnO2 is undergoing oxidation. So the reducing agent is also MnO2. Right? Now we need to calculate the stoichiometric coefficients. You know the n factor. You need to opposite the stoichiometric coefficients. So first for that, right? So the reaction over here, right? Now I will write the reaction over here and I will assign the n factor values oppositely. Okay. So if I write the reaction over here, ClO4 minus plus MnO2, right? OH minus gives rise to ClO minus plus MnO4 2 minus plus H2O. Okay. That is the reaction. First assign the n factor values, right? So n factor for ClO4 minus is 6. So that I will assign to MnO2. Okay. So here MnO2, the n factor is 2. That you are going to assign to ClO4 minus. Observe carefully here. 2 and 6. If they are divisible, they are divisible by 2. Both are divisible by 2. So always take the simplest ratio. If you take the simplest ratio, then you won't get mistakes. Your balancing of the redox reaction will be easy. So for 2:6, I will take 1:3. Observe carefully. For 2:6, I will take 1:3. Right? In place of 2, I will take 1. So in place of MnO2, I will take 3. So observe the reaction when you are solving. When you find the simple ratio, when you find these ratio, so always make it try to simple. Always try to make it simple. Now I am going to solve Cl1 Cl. Okay, here 3 manganese. I am also going to put 3 manganese. Now I am going to balance the oxygen atoms. Here so after that first try to balance the oxygen atoms and then finally balance the hydrogen atoms. So this reaction is in basic medium. So OH minus is coming here. So if you balance the oxygen atoms, right? How many oxygen atoms are there? 10. How many oxygen atoms are there? 10. If you check over here, how many oxygen atoms are there? 12, 13. Okay, 13 oxygen atoms are there. So to balance this, 10 oxygen atoms are there, 13 oxygen atoms are there, right? So as per the given condition, so in multiple choice questions, he will give the options. Based on the options, you need to substitute the values over here. Based on the options, you need to substitute the value over here, and you need to get the correct answer. So what I will take here is, right? Here I will take 3H2O and I will put 6 over here. I will take 3H2O over there and I will put 6OH minus over here. Based on the options, you need to select here. Okay, these are fixed. 1, 3, 6. So what are the coefficients? X equal to 1, Y equal to 3, Z equal to 6. Okay, if you check the charge, here 1 negative, 6 negative, total 7 negative. Okay, here also if you check the charge, 3 minus 6 minus 1, so 7 negative. So charge also same. So we can say this reaction is Balanced reaction. I repeat. So if you find the oxidation numbers, right, iodine is -1, Cl is +5, H2SO4 is plus 6, Cl minus is minus 1, HSO4 minus is plus 6, iodine is 0, right? So here if you take right iodine, there is decrease in oxidation number, so it is undergoing reduction. It is undergoing reduction. That means it acts as oxidizing agent. It acts as oxidizing agent. So there is no change in sulfur oxidation state, we can ignore that. There is no change in sulfur oxidation state, we can ignore that. While coming to the chlorine, right? While it is undergoing oxidation, it is act as reducing agent. It is undergoing oxidation, so it acts as reducing agent. So here N factor for iodine is 1. Okay. N factor for I minus is 1. N factor for ClO3 minus is 6. N factor for ClO3 minus is 6. That we are going to assign here, right? So iodine N factor is 1. Iodine N factor is 1. So that we are going to assign for chlorine. Chlorine N factor is ClO3 minus. The ClO3 minus, right? So the chlorine N factor is 6. That we are going to assign here. 6I minus. Okay. Plus H2SO4 gives rise to Cl minus plus HSO4 minus plus I2. Okay. Now balance. There are 6I minus are there. 6I minus over here. So put 3 over here. 6I minus is there. 6I minus is there. So put 3 over here. We are coming to here. ClO3 minus Cl minus Cl. Okay, balanced. Coming to next, balance to the sulfur balanced. Next we need to balance the oxygen atoms. How many oxygens are there here? 7. Okay, 7 oxygens are there. There we have only 4 oxygens. So I will put 3H2O. Right? Always we need to balance the oxygens by adding the water molecules. Always we need to balance the oxygen atoms by adding the water molecules. Here there are already 7, but there are only 4. By adding the 3 water molecules, right? The equation is balanced. Now by adding the 3 water molecules, the oxygens are balanced. Now we need to check for hydrogen atoms. Here the oxygens are balanced. We need to go for hydrogen atoms, right? There are how many hydrogens? 7 hydrogens. Here only 2 hydrogens. There are 3 2s are 6, 1 7 hydrogens, 2 hydrogens. Again you need to look into the options, right? The 6 and 1 are fixed. Again we need to look into the options to get the balanced equation, right? If I write 6 over here and 6 over here, okay, 6 over here, now the equation is fully balanced. Okay, if you check the charges, 6 negative, 1 negative, 7 negative. Okay, here also 6 negative, 1 negative, 7 negative. The charges are balanced. We want to check again 6 iodine, 1 chlorine, 6 sulfur. Okay, hydrogens are 12. There are 12 hydrogens. Okay, in such a way we need to balance the redox equation, balancing the redox reactions, and these are PYQs. Thank you.